So how do we do binary to hexadecimal? First thing we have to realize is that in decimal, 6, 7, 8, 9, and if we want to represent things as single spaces, this is as far as we can go. But how can we represent 10, 11, 12, 13, 14, and 15 in single digits? And that's the thing with hexadecimal. That is what we are doing. So this is decimal, and this is going to be our hex. Most of this is going to be pretty much the same, except when it comes to 10, 11, 12, 13, 14, and 15. But what about if we want to do in binary? Zero. That's the 4 position, that's the 1 position. That's the 8 position. Position 8 and 4. 13 is going to be 8, 4, 1. 14 should be 8, 4, 2, no 1. And then 15 should be all of them. And again, this is our decimal, and this is our hex. So why is this important? Because if I say, what number is this? 2, 0. I know that look like a 0, but that's a 0. So what exactly does that mean? Are we talking about the decimal number 20? Are we talking about the hexadecimal number 2 and 0? So it does matter. So let's look at this as the decimal number 20. Now if we were to take that and treat this as a decimal number, and we want to convert that to binary, we could go, oh, you know what, I want nothing in the 1 position, nothing in the 2 position. I want 1 in the 4 position, nothing in the 8, 1 in the 16, so 16 plus 4. I'm trying to do them in groups of 8. So that would be decimal to binary. Oh, I put my B wrong. So if this is our decimal number 20, that would be our binary number 16, 8, 4. But what happens if I really meant this was the hexadecimal number? And I want to convert that to binary. In that case, we are looking at because remember, if we're talking hex, 2, 0, they're different numbers. So you see where it kind of matters if we're talking, is this a decimal number? Is it a hexadecimal number? It does make a difference. Because this being a decimal number, converting it to binary yields one result. This being a hexadecimal number yields a different result. So do keep that in mind.